Hi, my name is Aiden Rosenberg, and for my final project, I decided to implement a program that loads in an OBJ and renders it with different shading and processing effects. The implementation of this project was based on the OBJ loader that I had already implemented in assignments 6 through 9. However, I needed to implement three main things to create my project: cell shading, using a frame buffer, and the post-processing effects. In this video, I will go through what I implemented specifically for this project. Let's just give a quick summary of loading an OBJ file. I did this by parsing the file, saving the vertices, vertex normals, and texture coordinates defined in the file, creating the unique vertices to render based on the unique combinations of vertex normals, and texture coordinates defined by the faces in the file, and then I created a material by loading the corresponding material file and any maps included within it. Now let's get into a little bit more detail about what I implemented for this project. First, we'll look at cell shading. To implement cell shading, while allowing for the loaded materials instead of just solid colors, I set ranges that the diffuse lighting value and the specular lighting value can fall into, and then assigned a set output value for each range. So instead of having soft shadows, the shadows are stepped, giving that cell shaded look while allowing the original texture to show. Now let's move on to using the frame buffer. Using the frame buffer was more complex than the shell shader, as I was referring to assignment 10, which had a lot of abstractions and used different and additional classes that I did not have. I was able to implement the frame buffer after referring to the assignment and learn OpenGL. Then all I had to do was make a shader for the frame buffer. What is rendered by the frame buffer is defined by what was written in the frame buffer GLSL shader files, and those files are able to use the image outputted by the first rendering process as an inherent trait of what frame buffers do. The last and most interesting piece of code, in my opinion, is the fragment shader for the frame buffer that applied the painterly looking effect, which you'll see later. The code here essentially implements the Kuwahara filter, which works by taking a window, centering it over each pixel, and then determining the pixel's value by getting the average color of each quadrant or window pane, finding the average standard deviation of the pixel colors in each quadrant, and then selecting the average color of the quadrant with the smallest standard deviation. That average color is set as the new pixel value, and the algorithm moves on to the next pixel. In this filter, the size of each pane or quadrant is variable. The larger it is, the more blurred and abstract the image will be. The number itself refers to the number of pixels between the center pixel and the topmost, leftmost, rightmost, or bottommost pixel. It is important to note that the pixels are vertically or horizontally in line with the center pixel are used in 2 quadrants, and the pixel itself is used in all 4. In this shader, I chose to use 9 as the width, meaning that there were 9 cells, the quadrants were 9 cells wide. My shader implements this described algorithm, as I just described, with the addition of checking to make sure that the pixels in the quadrant don't go outside of the bounds of the image. If they do, we just disregard them. This portion of the project took me the longest because in addition to figuring out how the filter worked, I had a hard time trying to understand how to determine the location of one pixel in any direction. After searching around, I was able to learn that I can get the size of the image provided to the shader, and then divide one by the width or height. Once I saw this and set it up, the result of the filter was a mostly smooth sailing, though it was difficult to debug and often resulted in a completely white output until I got everything working. I also want to quickly summarize a few other things I did for this project. I allowed the user to switch between the different shading and post-processing effects by pressing the numeric keys. I did this by having a function to change the shader, which looked at the number selected and set the associate shader object to a new shader object using the selected shader file. The user can independently change the shading effect and post-processing effect. Their options are regularly shaded object with material loaded, cell shaded object with material loaded, and cell shaded object in a solid purple color. Then, for processing effects, their options were no post-processing effects, painterly post-processing effect, and an outline post-processing effect achieved by applying the edge detection kernel to the image and setting the edges to black and everything else to the background color. In conclusion, this project was really fun to work on, and I really enjoyed working with different shaders, even though debugging it was somewhat difficult at times. Thank you.